everyone, and welcome to today's third grade math lesson. I've created a PowerPoint that I'm going to share. And this lesson is part 2 of our series on attributes and perimeter. And attributes are the characteristics, they're what we know about quadrilaterals. So they talk about the sides and the angles and things like that. So we will be talking about the attributes of quadrilaterals and the topic of perimeter. So for this lesson, you will need 3 materials: paper, pencil, and an eraser. So first, let's talk about the attributes of quadrilaterals. So what we know about quadrilaterals. So to start off with, we're going to review some vocabulary terms. So a quadrilateral, if you break up this word, then quad means 4 and lateral means sides. So a quadrilateral has 4 sides. Now, some other vocabulary terms to know are angle and right angles. So an angle is like a measurement. It tells us how large or small something is. And there's 3 types of angles that we're going to talk about in this lesson. There are right angles, which look like a capital L, such as this one right here. And they're always going to be the same measurement. Right angles are always the same measurement. So all of these are the same measurement. There's also something known as obtuse angles, and obtuse angles are larger than right angles. So if a right angle is a capital L, so it would go right about here, then an obtuse angle is even larger, so it opens up even wider. These 2 ones are also obtuse angles. So obtuse angles are larger than right angles. Now there's an angle that is smaller than a right angle, and that is an acute angle. And so acute angles are smaller than that capital L. So for example, here is an acute angle, and so is this one, and this one, and this one. These are all smaller than right angles. So if you look at the top right corner where my picture is, you'll see that I am showing a right angle right now. And if I make it smaller, then I have an acute angle, a tiny angle. And if I make it larger, then I have an obtuse angle, a big angle. So again, right angle, obtuse angle, acute angle. Right angle, obtuse angle, acute angle. Okay, now our next vocabulary word is parallel. And parallel means that the lines never cross or touch or meet. So for example, these vertical lines are parallel to each other. These diagonal lines are parallel to each other. These horizontal lines are parallel to each other. And for this rectangle here, the brown lines are parallel to each other. And the blue lines are parallel to each other. So that's parallel, meaning that the sides never meet, cross, or touch. Then there's something known as equal sides and angles, which basically means that the sides or angles are the same. So for example, our brown sides are equal sides because they both have that same length, as are the blue ones. Those have equal lengths when compared to each other. There's also equal angles, which means that those angles have that same measurement. So for example, all of these right angles are equal angles. They all have that same measurement. They're all that capital L. Okay, so now let's apply our knowledge of attributes for some different shapes. So this shape is called a hexagon. And so what I would like to know is, how many sides does our hexagon have? And are those sides equal? Meaning in length, are they equal? So first things first, let's talk about how many sides our hexagon has. Let's count them up. So our hexagon has 1, 2, 3, 4, 5, 6 sides. Our hexagon has 6 sides. Are these sides equal? Well, based on the labels and descriptions that are given, all of these sides are 3 inches. So they are all equal to each other. So again, we have 6 sides and all of those sides are equal. So we have 6 equal sides. Now let's talk about whether any of these are parallel. Are there any parallel lines at all in this hexagon? Well, there are. For example, this line and this line are parallel. They never cross or meet or touch. And I'm showing on the upper right-hand corner what this would look like. So they never cross or meet or touch. So that's one example of parallel lines. Another example could be this horizontal line and this horizontal line. And I'm showing it in my camera too. They never cross or meet or touch either. So that's parallel. That's our second example of parallel lines. Our third example of parallel lines is these ones. So we've got this line right here and this line right here. These could also be parallel. And I'm showing in my camera again. This is what they would look like. So they never cross or touch or meet. They stay parallel. So we've got, here's our first pair. Here's our second pair, the horizontal ones, and here's our third pair. So we have 3 sets of parallel sides. Now let's talk about the angles. How many angles are there and what kind of angles are these? So first let's look at how many angles. So I see an angle here. This is 1, then 2, then 3, then 4, then 5, then 6. So I have 6 angles total. Now we have to figure out whether these are right angles, as shown in my camera. This is a right angle, or obtuse angles, where it's larger, or acute angles, where they're smaller. So again, are these right angles, obtuse angles, or acute angles? Well, they look like they're bigger than a capital L, because a capital L is right about here, like that. But these are even bigger, which makes these obtuse angles. Same with this one, it's bigger than a backwards capital L. Same with this one, and this one, and this one, and this one. They're all bigger than right angles. So these are obtuse angles. So our answer for this is we have 6 obtuse angles. Now let's talk about the type of shape and its name. So I mentioned its name a couple of slides back. Do you remember what the name of the shape is? If you said a hexagon, you are correct. And it's a 6-sided shape. Okay, let's apply our knowledge to another shape. So once again, we're going to talk about how many sides there are and whether these sides are equal, or if any of the sides are equal. So first, let's talk about how many sides there are. Well, looking at our shape, there is 1, 2, 3, 4. 4 sides. And are any of the sides equal? Well, if we look at the top part and the bottom part, we can see that these have 2 different measurements. So these are not equal. But if we look at our sides, we see that this one is 4 feet and this one is also 4 feet. So these sides are equal. So we have 4 sides total, and the left and right sides are equal. So again, this side and this side are equal, but the top and bottom sides are not equal. Okay, so next we have to talk about parallel lines. Are any of these sides for this shape parallel, meaning that they don't cross or meet or touch? Well, looking at our 4 feet by 4 feet sides, we can see that, looking at my camera, these would meet. Eventually they would meet if the lines kept continuing. However, if we look at our top and bottom ones, the 8 feet and 5 feet, we can see that these would not cross or touch or meet at all. They would stay separate. So therefore, our top and bottom sides are parallel. Again, the ones outlined in orange are parallel. Next, let's talk about the angles. How many angles are there in the shape? And what kind of angles are these? Are they right angles, acute angles, or obtuse angles? So first, let's talk about how many angles there are. Let's count the angles. So we've got 1, this is 1 angle right here. Then we have 2, our second angle right here. Then we have 3, our third angle right here. And 4, our fourth angle right here. So we have 4 angles. Now, what kind of angles are these? Let's take a look at this one right here. Is this one a right angle, which I'm showing in my camera right now? This is a right angle. Or is this an obtuse angle, where it's larger? Or is it an acute angle, where it's smaller? If you said that this looks like an obtuse angle, you are correct. It's larger than a right angle. It's larger than a capital L. Because a capital L would be right about here. And this one is even larger, which makes it an obtuse angle. Let's take a look at this angle here. Is this one an obtuse angle, a large one? A right angle, where it's like an L, a capital L? Or is it an acute angle, where it's really small, even smaller than a capital L? If you said that this one is an obtuse angle, you are correct. Again, it is bigger than a capital L. So showing in my camera, if I have a right angle here, then even bigger would make it an obtuse angle, which we can see looks the same as the one in the trapezoid. Okay, so we have an obtuse angle here and an obtuse angle here. Let's look at the top right angle, this one right here. Does this one look like a right angle where it's like a capital L? Or does it look like an obtuse angle where it's bigger than a right angle? Or does it look like an acute angle where it's smaller than a right angle? If you said that it looks like an acute angle, you are correct. It is a small one. And that goes for this one as well. This one is also an acute angle. It is really small. So notice the difference between obtuse and acute angles. Obtuse angles are really large. Acute angles are much smaller. So for our answer, we have 4 angles, and what kind of angles are they? We have 2 obtuse angles, 1, 2, and we have 2 acute angles, 1, 2. So 4 angles, 2 acute angles, and 2 obtuse angles. Now my last question for this particular shape is, what is the type of shape? Like, what is its name? And there's 2 different names that this could have. So the first name is going to be a trapezoid. This is a trapezoid, but there's also another name, and it starts with a Q. Do you know what this name is? So this shape is also known as a quadrilateral, which is one of our vocabulary words in the beginning of the lesson. And again, quad meaning 4, lateral meaning sides. So a quadrilateral has 4 sides. 1, 2, 3, 4. So quadrilateral meaning 4 sides. So now I'm going to let you apply your knowledge to one last shape, this shape right here. Okay, so now using your paper and pencil, you can write down how many sides this shape has, as well as which sides are equal. So I'll let you pause the video and write down how many sides there are and which of the sides are equal. Okay, so now let's check our work. So we have 4 sides. So we've got 1, 2, 3, 4. 4 sides. And let's take a look at their lengths and widths. Well, we see that the side on the left has 9 feet, and the side on the right also is 9 feet. So we know that these 2 sides are going to be equal because they both have 9 feet. If we take a look at our top and bottom ones, we see that both of these are 4 feet, which means that these are equal to each other. So our answer will be that there are 4 sides for the shape, and the lengths are equal and the widths are equal. So the lengths are equal to each other and the widths are equal to each other. Okay, so now my next question is, are there any parallel lines? And if so, which ones? So again, parallel lines, and if so, which ones? So let you pause the video and write down your answer. Awesome, so now let's check your work. So there are going to be 2 sets of parallel lines. The lengths are parallel and the widths are parallel. So we can see that these measurements of 9 feet, which I'm also demonstrating in the camera, they never cross or meet or touch. They stay parallel. So this is one example of parallel lines. Our other example is the top and bottom lines. These also never cross or touch or meet. Those are the 4 feet ones that we have. So 2 sets of parallel lines. The lengths are parallel and the widths are parallel. So for our next question, we're going to talk about the angles. So on your piece of paper, I'd like you to write down how many angles there are and what kind of angles these are. And again, your options will be right angles, obtuse angles, or acute angles. And I'll demonstrate each in the camera. So here's a right angle, looks like a capital L. Here's an obtuse angle where it's larger than a right angle. And here's an acute angle where it's smaller than a right angle. So again, you're going to write down on your piece of paper how many angles there are and what kind of angles they are. So I'll let you pause the video and do that. All right, so now let's check your work. So there are 4 right angles. So I'll show each of the angles. So here's one angle. Here's our second angle. Here's our third angle. And here is our fourth angle. So we have 4 angles. Now for the question of what kind of angles these are, well, this angle right here looks like a capital L. That means that it is a right angle. This one is a backwards capital L. This one and this one also resemble L's. So all 4 of these are going to be right angles. All right, last question for this one. What is the type of shape and its name? And there's 3 different names for this one. And I want you to write down at least 1 or 2 of the names for this particular shape. So I'll let you pause the video and write down its names. Okay, so now it's time to check our work. So it has a couple of different names. So the most common one is a rectangle. This is an example of a rectangle. It's also a quadrilateral. Again, quadrilateral meaning 4 sides. And this has 1, 2, 3, 4 sides. So this is a quadrilateral as well. There's another vocabulary term, which is a parallelogram. This is also a parallelogram because it is 2 sets of parallel sides. So quadrilateral, rectangle, and parallelogram are all terms that could describe the shape. So now we're going to go on to a new concept, which is perimeter. And perimeter is when you add up the lengths and the widths for all the sides to find the answer. So I'm going to demonstrate this one. So this one is finding the perimeter of the rectangle. That's what we have to do. And we have to include the units. So units are things like inches, centimeters, feet, meters, kilometers, all of those. So we have to find the perimeter of this rectangle, including the units. So to solve for this, I would first fill in the missing sides. So beforehand, I only had 7 and 4. I only had 7 and 4. I have to fill in this length and this width. So that's what I did. So these are equal sides. They're both the same length, which means that if one side is 7 inches, then the other side will also be 7 inches. So that's why I put that 7 there for this. Same with our widths. If one width is 4 inches, then this width is the same length and equal length. So this is also going to be 4 inches. So that's how I get my 7 and my 4. So to find the perimeter, I need to add up all of the lengths and widths. So I'm going to start out with 7 inches plus 4 inches plus 7 inches plus 4 inches. That's what I have right here. P for perimeter equals 7 inches plus 4 inches plus 7 inches plus 4 inches. Now the order in which we add this doesn't matter. For example, I could have started with this width. I could have started with 4 inches plus 7 inches plus 4 inches plus 7 inches, and it gets me the same answer. So as long as I'm adding up all of the sides, all of the lengths and widths, I'll still get the same answer. So when I add these numbers together, 7 inches plus 4 inches plus 7 inches plus 4 inches, I get 22 inches. So my perimeter for this rectangle, this quadrilateral, this parallelogram, my perimeter is 22 inches. So let me show another example. So our instructions are find the perimeter of the equilateral triangle. Equilateral means that all of the sides have the same length. And we have to include the units. So we can see that this side is A, this side is A, and this side is A. And we have A equals 7 inches. So in other words, this side is 7 inches, this side is 7 inches, and this side is 7 inches. I have to find the perimeter. So first things first, I crossed out my A and substituted it, which means I replaced it with 7 inches because A equals 7 inches. That's why I crossed out each of the A's and put 7 inches instead. So to find the perimeter, I have to add up all the sides. So I'm going to do 7 inches plus 7 inches plus 7 inches, and that's what I have right here. Again, you could start with any of the sides. I could have started with this side, for example. I could have said 7 inches plus 7 inches plus 7 inches, and they'll still get me the same answer. So P for perimeter equals 7 inches plus 7 inches plus 7 inches, which equals 21 inches. So the perimeter of this equilateral triangle, which means that all of its sides are equal, is 21 inches. So now let's find the perimeter of this picture, including the units. So I'm going to let you do this one by yourself. Okay, so our length is 7 inches and our width is 5 inches. That's what they give us. So I'm going to let you solve for the perimeter and include the units. In this case, the units are going to be inches. So I'll let you pause the video and find the perimeter. Okay, so now let's check your work. So the perimeter means that we add up all of the sides. So in this case, we have 7 inches plus 5 inches plus 7 inches plus 5 inches. And that's what I have here. That's my equation. P for perimeter equals 7 inches plus 5 inches plus 7 inches plus 5 inches. So what I did is I added up all of these sides. And when we add them together, we get 24 inches. So our perimeter of this picture frame equals 24 inches. Again, that's 7 inches plus 5 inches plus 7 inches plus 5 inches. So I hope that you enjoyed today's math lesson on the attributes of quadrilaterals and perimeter, and I have thoroughly enjoyed teaching you math, and have a wonderful rest of your day.